Next, I will explain the project endpoint. Cloud management operations in WolkenInsight.
After entering the main interface, click New Project, and the application will create a blank project for you to work with. Next, click the Import Point Cloud button and select the point cloud file you want to import. After selecting and confirming the file, a dialog will appear. Follow the prompts to select information such as the point cloud scene and the scanning device. After the point cloud is imported, you can interact with it. In the display view, hold the left mouse button and drag to rotate the view. Hold the mouse wheel and drag to pan. Scroll the mouse wheel or hold the right mouse button and drag to zoom in or out. The Properties panel on the right displays the basic information of the point cloud. If the required information was not entered during import, or if incorrect information was entered, click the Modify button in the lower right corner to update the corresponding fields. Next, I will introduce the point cloud quality inspection functions in WolkenInsight. The first function is density and uniformity calculation. When using this function, the application will open a dialog for setting the search radius. In general, the search radius should be set between 0.05 and 1. A search radius that is too small may produce incorrect results, so you may increase it as needed. However, the larger the radius is, the longer the computation will take. After clicking OK, the application will spend some time calculating density and uniformity. Once the calculation is complete, the Properties panel on the right allows you to display the result either as a heat map or by threshold. When displaying by threshold, a slider will appear below the drop-down menu. Drag the slider to adjust the density or uniformity threshold. Values below the threshold will be shown in red. While values above the threshold will be shown in white. Click the drop-down menu in the Properties panel to switch the item you want to preview. The display rule for density is the same as that for uniformity. Next is the Missing and Occluded Area Detection function. Please note that this function currently supports only outdoor point clouds. Import an outdoor point cloud and make sure its scene attribute is set to outdoor during import. This function also needs to call the WolkenInsight service. You can open the global settings in the upper right corner and click Test to confirm whether the WolkenInsight service is connected. After confirming that the service is connected, click Detect Missing Areas. A dialog will appear for setting the relevant parameters. The smaller the grid size is, the more finely the point cloud will be divided, and the more missing area problem points will be detected. At the same time, computation will take longer. We recommend setting this value to no less than 0.5 meters. The smaller the height threshold is, the fewer missing areas will be overlooked, but the more false detections may appear. Minimum component points represents the minimum number of problem points required in each missing area. The smaller this value is, the fewer areas will be missed, but false detections may also increase. Minimum component distance represents the minimum distance between missing areas. If you find that multiple missing areas have been connected into one large region, you can reduce this value appropriately. In addition, we recommend enabling the option to treat walls and windows as a single unit. After setting the parameters, click OK. The application will spend some time calculating the missing and occluded areas and generating the corresponding reskin points. When the Preview and Edit Reskin Points interface is opened for the first time, the application will highlight all detected missing and occluded areas in the central preview area using red and yellow points. If the highlighted points are difficult to see, adjust their size using the Problem Point Size slider on the right. You can select an item from the Missing Area list at the top to display a specific missing or occluded area individually. The application uses a green sphere to mark the reskin point and a yellow arrow to indicate the reskin direction. Click Flip to reverse the current reskin direction. Click Rotate to rotate the reskin direction by 180 degrees on the horizontal plane. You can also drag the sliders to adjust the sensor yaw angle, the rotation around the z-axis, the pitch angle, and the distance between the sensor and the missing or occluded location during rescanning. If the modification is incorrect, click Reset to restore the settings of that point to their initial values. If the modification is correct, click Apply to apply all changes to the point. Next, I will introduce the automated semantic and instance segmentation functions. These functions need to call the WolkenCept service, so please make sure the service is connected before using them. In the Category module, click Calculate Classification to calculate the semantic information of the selected point cloud. Please make sure that the point cloud to be processed includes information about the acquisition device and the application scene. In addition, we strongly recommend preprocessing the raw point cloud collected by the device with third-party tools first and importing only the region of interest into WolkenCept for analysis. This can greatly improve the segmentation speed in WolkenCept and reduce the possibility of WolkenCept recognition errors caused by extremely sparse point clouds. After semantic segmentation is complete, the software will automatically switch to the segmentation result visualization interface. Here, you can view each semantic category individually and export them separately. In the panel on the right, double-click a category to modify its preview color. You can also choose to use RGB information instead of a solid color display. You can also view the confidence score of the semantic segmentation result. In general, when the confidence score is below 85%, the AI model is no longer very certain about the category assignment of that point. You can display the result as a heat map or by threshold. When using threshold display, the dual slider component can be used to show points within any confidence interval. You can then export these points or export them while applying downsampling. We recommend post-processing the semantic segmentation results for smoothing and denoising. After clicking Smooth Categories, the application will prompt you to set to parameters. Smoothing and denoising will only process points below the confidence threshold. The number of neighboring points determines how many nearby points the application will use for denoising. After clicking Confirm, the software will perform denoising and automatically overwrite the original classification result. Next, I will introduce the tree individualization function. First, import an outdoor point cloud that contains vegetation, and select Outdoor Scene during import. After import, semantic segmentation must first be performed on the outdoor point cloud. When semantic segmentation is complete, click the Tree Segmentation button, and the software will automatically perform individual tree segmentation on the point cloud. You can view the progress of tree individualization in the progress bar at the bottom. If you want to cancel the process midway, click the Cancel button in the lower right corner. After the calculation is complete, the software will automatically switch to the Segmentation Result Visualization interface. Here, you can highlight and export individual instances. The panel on the right will also display tree parameters such as coordinates, crown width, diameter at breast height, and height. Next, I will introduce the building instance segmentation function. After importing the building group point cloud to be processed, you also need to perform semantic segmentation on the outdoor point cloud first. After semantic segmentation is complete, click the Building Segmentation button and the software will open an algorithm settings window. Because the original point cloud must be downsampled before the algorithm can run properly, you need to set the average point spacing after downsampling. The number of neighboring points refers to the number of nearest neighbors required to calculate the normal vector of each roof point. This parameter determines the neighborhood range considered during normal vector calculation. The angle threshold refers to the threshold for the angle between normal vectors of adjacent points in the roof point cloud. Only when the angle between neighboring normal vectors is smaller than this value will the points be clustered together. The projection distance threshold refers to the vertical distance threshold between a point in the roof point cloud and the roof plane. If the vertical distance from a point to the plane is smaller than this threshold, the point will be clustered into the same group. The minimum side length of intersecting planes refers to the minimum side length required for each clustered roof surface. If the side length of a roof surface is smaller than this threshold, that roof surface will be removed. The plane fitting distance threshold is used to determine whether adjacent roof surfaces should be merged. If the distance between adjacent roof surfaces is smaller than this value, the system will try to merge them. After the building instance calculation is complete, the software will automatically switch to the segmentation result visualization interface. Here, you can highlight and export individual building instances. Next, I will introduce the WolkenRefinery module, which is used to manually correct segmentation results. Switch the top toolbar to the Refinery tab. Two selection methods are available here: polygon selection and rectangle selection. You can use either method to select the area that needs fine adjustment. You will then enter the main refinery interface. In the 4-view layout, you can drag with the left mouse button to rotate, use the middle mouse button to move, and use the right mouse button to zoom. The available operations may vary across different views. The upper left view is the top view, the upper right view is the free view, the lower left view is the front view, and the lower right view is the right side view. In the Display Settings section, you can choose to display the point cloud in RGB mode or in colored mode. You can also toggle the display of surrounding point clouds and adjust the point size. After selecting the category to be corrected under the current classification, click the buttons in the Segmentation tool area to perform further refinement. Rectangle and polygon segmentation tools are also available here. After completing the cut and confirming the area to keep, you can assign the region to a specified new category at the bottom. Then click OK and follow the instructions to confirm the classification, result, or undo the operation. After exiting the refinery interface, you can see that the previously edited region has been assigned the new semantic category.